Hey, good evening, everybody. Welcome aboard the threat hunting train. We're about to leave the station this evening. We have got a very special guest in the house tonight. We have Seattle's own Randy Pargman. Hey, Randy, thanks for
Hey,
joining
everybody.
us.
Absolutely. Thanks for having me on. It's my pleasure.
It is the pleasure is mine, sir. I'm so such a fan of your work, especially we talked before. This threat hunting is so interesting to me. It's like, gosh, if I were to pick one thing that just offered it all and would keep me hooked forever, this is one of those things in the cyber field. And I'm so happy we get to share this with the CSMP community. I think everyone's pretty pumped to get to see what you've got to display for us through Jupyter Notebooks this evening. And I'll basically let you take it away. I think we're all set here. I just wanted to remind everyone we've got the next webinar coming up next week is all about how to build up your own virtual sandbox at home. So if you're still figuring out those little details, I'll be happy to answer any questions you might have and help you get some sandbox cyber action going on. But today, uh, Randy, the floor is yours. Take it away.
All right, thanks. Well, first, I would like to ask you to enable screen sharing so that I can share a presentation.
Yes, let's do that.
And while you're doing that, I just wanted to mention that course on building up your sandbox, that is going to be outstanding. I just know that's something that if you haven't done it before, if you're not quite sure what sort of things you could have in your sandbox that's going to be useful to you, definitely attend that because the um, the environment that you build for yourself is absolutely the best way to learn, or at least that is for me. Like that is something that I am constantly tweaking and building better and collaborating with other people and trying to make the most realistic sort of environment that we can get because it lets you just experiment freely, right? Like I work every day with global companies, networks that have over 100,000 endpoints on a single network, and I can't just go messing around with their systems and trying out some malware techniques and setting off all the alarms. But I can do that on my own systems, right? And in fact, I'm going to share with you some of the stuff that we've done and the things that you learn when you actually see it in actual practice, like using the same tools that you're going to be using in real life, but in your own controlled environment. This is an outstanding way to experiment and through experimentation to learn. So what I'm going to be talking to you about tonight. Oh yeah, chaos engineering. Absolutely. That's a quick way to lose clients. So I'm not a big fan of that. But it is a whole lot of fun to have that chaos on your own controlled environment. So what I'd like to share with you tonight are some techniques that have been really helpful. And I'm specifically going to be talking about Jupyter Notebooks. And just taking kind of a poll of the audience, it looks like a few people have used Jupyter Notebooks before. Some people have programmed in Python, but a lot of people haven't. So I'm going to try to slow down a little bit and just take some time to explain. But I'm also going to try to watch the chat. I'm terrible at watching chat and speaking at the same time, so bear with me. But if you are lost or you just want to ask some questions, I think that will be really helpful for everybody because if you've got a question, probably somebody else does too. So let's get started. First of all, what is the threat hunting hypothesis that we're starting with? There are lots of different ways to do threat hunting, but we usually start with some kind of hypothesis. And I mean, it's not a big mystery. It's not rocket science. It's just coming up with an idea about what do you think a threat actor is going to do to evade detection in your environment. Now, if you are in the process of threat hunting, you are probably not worried about viruses that are old and that antivirus can detect, right? Like, hopefully you've already deployed that. You have AV everywhere. You know that if somebody puts a well-known piece of malware onto your network, that it's going to be stopped pretty soon. It's definitely going to be recognized. the whole process of threat hunting is going above and beyond the static defenses or the automated defenses that you have in place, and asking yourself the question, if I were the threat actor going after my network, and let's just say that I was really good at what I do and I had studied all the defenses and I knew what was in place. Worst case scenario for the defenders, a determined adversary targeting you specifically who knows your environment. What would you do in order to operate freely for, at least hours, but probably days or weeks at a time without being detected? Now, if you are thinking of that question and you have absolutely no idea where to start, if that is just blowing your mind, like, well, I don't know, if you got a good defense and antivirus is there, like, how am I going to get anything on? Well, that is an indication to you that you need to study some offensive security. And don't let anybody ever tell you, like, the blue team doesn't need to know red team skills. You absolutely need to. I'm seeing William is raising a hand. Go ahead and just chat in the chat and I'll see your message. If you study red team skills, if you know how to be an operator of an intrusion, then you can start experimenting by actually running some intrusions in your own lab environment, watching those with all the signals that you have, and then trying to figure out, okay, what would I do in order to not set off any alarms, right? So that is the general approach that we always take with threat hunting. We put on the black hat and think about what the threat actor is going to do, and then we try to experiment and come up with a solution so that we can close that detection gap, so we can actually detect if somebody is doing that really sneaky thing. So our hypothesis right now is that if a threat actor needs to have remote access to your system, there's a few different ways they could do that, but one of the most common ways is implanting malware. So some process that is running, whether that's in a script or injected thread into some legitimate process, or it's just an executable running all on its own. Something is running on the victim's computer. Usually they get it there through some kind of social engineering, some phishing, downloading some malware, convincing somebody to do it. I was actually just talking to a malware operator on the phone today who had a really clever trick. They would actually send email with no attachments, no links, no malware, no nothing. All it was just a plain text message that would sail past any kind of threat system that said, hey, your free trial has expired and we're going to start charging you $89 a month starting today. Thank you for your patronage. Here's our phone number. So people who get that message, they of course call the person on the phone, right? They're like, I didn't order anything. So that's what I did. I said, I knew what this game was, but I called them specifically to see what would happen. And I said, I got this message, I didn't order anything. And they directed me to go to a website and to download an Excel spreadsheet. And I asked, why do I have to download an Excel spreadsheet in order to cancel this order that I never put in? I didn't subscribe. And the answer they gave me was hilarious. They said, the FBI and the police are investigating. There's somebody who's just placing all these fraudulent orders and we're collecting evidence for them. And if you open the spreadsheet, then that will make it official. Gosh, that doesn't even make sense, but I pretended like I was. I actually did download the spreadsheet and I was analyzing it in a sandbox while we were talking. And it was completely full of malware. But anyway, somehow or another, the threat actor is going to get that malware onto the endpoint system. And then for a piece of software, any software that is running on the victim system, probably behind a firewall, probably does not have a publicly addressable IP address that's listening to some ports. If the threat actor wants to have remote control over that system, it has to make outgoing communications, right? I mean, does that make sense? It must, if it can't accept incoming, it must be making outbound communications. And that is the way that most malware works that I study. If that malware is making outbound communications, there's really two choices if the threat actor wants to be able to interact with it. One is that it will start an outbound communication and just hold that TCP connection open for a really long time. Like, think about that. If you've ever used SSH, you know exactly what I'm talking about. You make the TCP three-way handshake, you negotiate the encryption protocol, you establish the connection, and now you've just got an open socket that stays open a really long time. So that would be one way that we can hunt for unusual processes or unusual network connections in our environment. We would just look for any long-lived connections. But the more common way, by far the more common way that almost all malware uses is not a long-lived open connection. It's actually repeating connections, something that goes out every once in a while and makes a connection to the threat actor's command and control server, or more likely it's a proxy server that then redirects it to the threat actor's real server. So that is the hypothesis that we're working with here. It's important when you're doing threat hunting not to make your hypothesis too wide. Like you can't say, okay, today I'm going to solve the problem of all malware communication and I want to detect everything. Like that's too big. So let's focus on this one thing. But I mean, this one thing is a really common thing. Like I said, almost every malware does this. So question, how do you eliminate connections which are regular and legitimate? ASN, the autonomous system name or number. So unfortunately, you can't. I'm going to show you an example here where the repeated outbound communication is to a legitimate Google URL and IP address using script.google.com, which is user-controlled content, and it just forwards on from script.google.com to the threat actor's command and control server later on. So you can't just decide that things are good looking at the network traffic. What you can do, though, is you can look beyond the network traffic at the process that is creating that and then make sure that it makes sense. And we're going to get into that, so I will save that for a little bit later in the presentation. Also, the question beacon question mark. Yes, this process of making outbound regular communications in common parlance is called a beacon. Beaconing malware or malware beacon, or in fact, there's a really popular piece of red team software called Cobalt Strike, and the implant that it puts onto the victim computer or the computer under test is actually called Beacon. Like that's the name of the software. But beacon in general means regularly repeating outbound communication. So if you look at the slide that I've got up here, this is a time chart of number of connections over time, and you can see this pattern. This is extremely regular. This is a piece of malware called Baza Backdoor. I won't get into why it's named Baza, but it's short for Bazar, B-A-Z-A-R, not with a double A, which is reference to the Immercoin DNS name that it uses. But anyway, this is a piece of malware that's really common. It's really active right now. So this is the pattern that we're looking for. Now think about the way that other processes make connections. Most network connections are on your network, on an enterprise network, are a result of email, Microsoft Teams, if you've got Teams or whatever chat app you've got, Mattermost, Slack, whatever, and people web browsing, right? People are web browsing constantly. So most of those don't look regular like this, right? Like there's constantly repeating communication, but it's not on this really regular basis. So the good thing, the pros about looking for malware through beaconing is that it does not matter if the IP address is suspicious or not. Like even if the malware is communicating out to Google and you've got bazillions of other processes also communicating to Google, you can still find the malware. That's pretty cool. It also doesn't matter if the port that it's communicating on is a usual one that blends in or a really unusual one. It also doesn't matter if the traffic is encrypted or not. Like it doesn't, you're just looking at the shape of the traffic, the timing of the traffic, that's it. So even if it's terribly encrypted, or even if it just blends in completely with all the other traffic otherwise, as long as the timing stands out, which it does quite often, this is a good technique. This is not a good technique if the threat actor, yes, Rita, you're getting ahead of me. That is a perfect tool. We're going to talk about that. So it does not work really well if the threat actor is using DNS as their command and control channel, because DNS is making queries through your own DNS server, which is totally normal. It's not going out to like an outside server. and the connections might not be all that regular. There's other ways you can find that though. So if you're interested in that topic, I could probably do a whole nother webinar just on DNS for command and control, but it's highly unusual. Most traffic, most malware in actual practice does not use DNS because DNS is really, really slow. If you want to try to transfer a file out over DNS, it's crazy. It's also not very good if the check-ins from the malware are infrequent. So if you were paying attention to the SolarWinds hack, those backdoors that were implanted would call out like one time in a 24-hour period. When you've got that infrequent communication, doing network traffic analysis isn't going to help you. You've got to find it other ways. So let's talk about ways to accomplish this. Congrats to Sai Sharma, I hope I pronounced your name right, for suggesting Rita. This is actually kind of the canonical tool for doing this. Rita has been around a long time. I discovered it and just fell in love with Rita many years ago when I was taking a SANS course. And it came up and I was like, oh my gosh, this is great. And it's free software. So the thing about Rita is that it works only if you have Zeek. You have to have Zeek logs, and Zeek is the another software. What was it, 504? Gosh, I don't even remember which one it was. I think it was 503 actually, the SANS class. But Zeek works by deep packet inspection of your network traffic, which means you have to have a computer with visibility over all your network traffic that can run Zeek to produce these logs. So I've got that actually set up. I have Zeek running all the time, monitoring the traffic for a VPN, but I can tell you it's a little bit difficult keeping Zeek happy. Like I have an alarm that pings me and wakes me up if Zeek fails, and it always fails in the middle of the night. I don't know why. It's picky at midnight or at 2 a.m. So anyway, and then I have to get up and go restart Zeek. It's a little bit difficult. So Zeek works, but it's kind of finicky and it requires that network visibility. Sometimes, like when you have a whole bunch of employees working from home, if they're not all going through the corporate VPN, like if you've got some kind of split tunnel or something, you might not even have that position where you can see the network traffic. You might be out of luck there. So what else could you do? That's really the question. If you've got Zeek logs already, just use Rita. Like easy answer, use Rita, it'll work. But let's say you've got something else. How does Rita compare to Wireshark? Like apples and oranges. So they're not the same thing at all. Rita is specifically looking at Zeek logs to find patterns that look like beacons. Wireshark is a tool that you, the analyst, can use to peer into every single byte of every single packet and figure out what it means. Wireshark would be a terrible tool for finding beacons. It's a great tool for dissecting an unknown protocol. Rita is a great way to do that. Oh yes, is Zeek similar to Suricata? Very much so. In fact, on the VPN that I've got running, I have Suricata and Zeek running at the same time on the same very small Azure VM. And I actually love Suricata because it never fails. I never have to wake up at 2 in the morning to fix Suricata. So it's got my love. But it doesn't quite have the same detail that Zeek does. So that's why I still have both. All right, so if we want to measure network traffic, we want to look at the timing of network traffic, but we don't have network visibility, what are we going to do? Well, we've got some options, and they're all on the endpoint. If you can deploy to every one of your endpoints, Microsoft Defender for endpoint, that costs money. You have to pay Microsoft. Either you need an E5 license, which is crazy expensive, or you need to pay like $5.10 per endpoint per month, and then you can have Defender for endpoint. That's a great product. We use it a lot. I really like it. Defender for endpoint is one way that we can do this. The other way that we could do it is with Sysmon. And what I like about Sysmon is it is free. It's in free beer, like $0. It's also from Microsoft. It is not supported. Of course, Microsoft isn't going to support a free product, but it pretty much works. And you can find a large community of other people who use Sysmon that if you have something broken, you can kind of figure it out. Now, I will say, having deployed Sysmon at large scale, every once in a while on some machine, because of driver conflict, it's always some driver conflict, it'll blue screen the computer. So, I mean, if it fails really hard because it is a system driver. So if it's trying to do something that just does not get along with some other system driver on that particular system because the mix of the hardware or whatever, like you might not be able to run sysmon on that machine. But it's pretty rare. Like you can deploy sysmon, 10,000 times and maybe have one machine that it doesn't work on. Yeah, Microsoft E5, $57 per user per month. You get a whole lot more than Defender for Endpoint. You get a whole bunch of stuff, but I'm not gonna try to defend that pricing because I think that's really expensive and crazy. Some organizations totally can afford it. It's not a problem for them, but for students, yeah, ATP, super nice. In fact, Microsoft changed all of their branding. It used to be Defender ATP was their EDR product. Now it's called Defender for Endpoint, which is terrible. They shouldn't call it Defender at all because Defender is the free antivirus, but don't get me sidetracked. Anyway, so sysmon is what we're going to use quite a bit, and this is what I recommend for your home lab. You can get so much information. In fact, almost everything, every piece of information that you can get from Microsoft Defender for Endpoint, you can get from sysmon. Almost. There's a few things that are missing. And this is even better. There's some things that sysmon does that Defender for Endpoint doesn't. And those things happen to be super valuable for threat hunting. So don't think you're getting shortchanged at all by using the free product. Definitely check out sysmon. It takes some config, it takes some know how to do it, but sysmon works really well. You could also choose to use PacketBeat, which is purpose-built for this type of application. It is software that runs on every endpoint. It keeps track of the net flow and it reports back into a central server. You need an Elastic server to run that. Or you could run Suricata, but you also need network visibility in order to do that. So we are going to take those top two bullets and expand out on those for this presentation. We could get into the other ones, but we'd run out of time. So ingredient number 2, now you've got the data collection, right? You need to send it somewhere. I mean, if you've got just one endpoint on your network, then you have a very easy to defend network. But probably you have at least hundreds, if not thousands, or maybe tens of thousands. And you need all of the information to go to a central point. So there are lots and lots and lots of options for doing that. And a lot of them are really expensive. You can set up ELK, the Elasticsearch, Logstash, and Kibana, pretty much for free. I mean, you're gonna have to pay for the hardware and run it, and you need to configure it. But we've actually got one of those ELK stacks on our lab network. It works really well. It's not bad. There are a few things that I don't like about the way that Elastic works that sometimes require like a lot of extra work to do pre-processing of logs if you want to get something special out of it, but that works. So that is definitely an option. You could also use Splunk. Splunk is very expensive, but if you've got a small enough project, there is a free tier that you could probably, or like for a short amount of time, you could run Splunk and that would work too. You could run MongoDB. That's what Rita actually uses under the hood. So that would work here too, but you're gonna have to roll your own solution completely. Like there's nothing that just takes logs from sysmon and puts them into MongoDB. You're gonna have to write all that software. Or you can do what we're gonna show you, what I'm gonna show you in this presentation, use Azure Sentinel. So Sentinel is cool. Okay, what about AndDB? Any DB. Okay, yeah, so pretty much any database. Like I just mentioned Mongo because Rita used it, but you can use anything. Anything will work. So I actually use Sentinel quite a bit. We've got a lab that uses Sentinel. I've got several clients that I work with who deployed Sentinel at a very large scale. I have to say it works really, really well. And what I like about it the best, selfishly, just for myself, is that there is no cost, no base cost to running Sentinel. So you can like spin up a Sentinel instance in Azure, and if you're not sending any logs to it, you're not paying anything for it, which is pretty cool. And I think you can still get 90 days totally free of Sentinel, no matter how many logs you put to it, or there's some upper limit, but it's pretty reasonable. If you just want to kick the tires for 90 days, totally free. But for a home lab, this is great because you're not paying for it while you're not using it. You can choose how much log volume you're going to ship to it. And the cost to process logs is like $2 and something cents per gigabyte. And you'll pay that monthly. So Throughout the month, however many gigabytes of logs you've shipped to Sentinel, you'll pay $2 and something for that. So for a a lab with like 5 virtual machines, all of them shipping a mad amount of data, you're probably gonna still be like $5, definitely under $10 a month. And then if you want to stop paying for that, but just keep your data around for a while, you can do that too. Like the next month, if you don't ship any data to it, you don't pay anything for it. You can keep the logs in Sentinel for up to 90 days for free, which is what I do, because if I haven't figured out what I'm doing after 90 days, then it can just go away. If you want to, though, if you want to keep those logs long term, you can actually export them out of Sentinel and put them in blob storage, or just download them and save them on an external disk or whatever. So you could store your own logs, and you're not paying for that either. Anyway, enough about Sentinel. That's what we're going to use. And definitely, I'm going to be getting with David later to show him around Sentinel. So hopefully you'll get to see how to hook that up in your own lab. I think it's really useful. And then ingredient number 3, we need some system to query this data from the database. Now, Sentinel itself has this language called Custo Query Language, KQL, which is the same log processing language or same log query language that all of the Microsoft logging solutions use. So it is absolutely worth your time to learn KQL. It's actually not that hard, especially if you've ever done any SQL. If you've ever made your own database and run SQL queries against it, KQL makes a lot of sense. Like you can do things like union or left outer join or an inner join on this pivot key or whatever. Like it makes a whole bunch of sense. You don't actually need to define the database. That's all defined in Sentinel already. You just need to learn KQL to query it. I'm going to show you some of the KQL. Believe me, like when I first approached this was, hey, I've got a new client who's coming on and they're using all this Microsoft stuff and it uses KQL. And I was like, oh, shoot, a whole new language to learn. Like I wasn't looking forward to it. I should have been, but I wasn't. And I tried to go through some Microsoft seminars and stuff, and like it didn't click. And then finally, I just got hands-on with Sentinel. I started playing with it. There is a PDF for free called "How to Become a KQL Ninja," and it just kickstarts you right off the bat, like learning stuff. And once you get the hang of it, I promise you, it is way easier than it looks. So we're going to use Jupyter Notebooks. Here's a slide. If you want to just take a picture of this for later. These are the things that we're going to be using. I used Sysmon version 13.0.1 because it had some cool new features, and 13.0 crashes everything. So definitely get the latest version of that. Also use Microsoft Defender for Endpoint, Sentinel, and Jupyter Hunt Server with Mystic Pi. Mystic is the Microsoft Threat Intelligence Center. And they have these Python modules called Mystic Pi, and then Matplotlib to render charts and graphics. So if you've never seen a Jupyter Notebook before, this is what it looks like. And let me just demystify Jupyter Notebooks right away. I heard people talking about them for so long before I actually looked at it myself, and I was a little intimidated because I was like, I have no idea. This sounds like a brand new technology. It's not. It's really simple. All it is just a place to run Python scripts with documentation around it. Like, that's it. It's nice and convenient because there's all these things that are all installed and you can do nice rendering. Like one of the things I always have trouble with Python is unless I'm making a web server, or I'm making something that has web output, I'm going to interface with it through a browser. Unless I've got that, having some kind of graphical output is kind of difficult. I've done lots of things to get around that. Like I used Pygame, which is a framework for making 2D games. I used that to like draw graphics on the screen. It kind of worked, but it was a little kludgy. But usually what I just default to myself is I just have text-based output, or like just output to a file. Like if I need analysis output, I'll just use XLSX Writer, XLSX Writer, that module, and make an Excel spreadsheet, and then I'll just open up the Excel spreadsheet and work from there. But what I like about Jupyter Notebooks is you've got this web interface without having to like write a Flask application, or you don't need to deal with any of that stuff. You can just say render a chart, and it just renders a chart, and it's really nice. Or you can have text-based output if you want, but it all goes into this this web page. And then um, each area of this Jupyter notebook, you just start with a blank notebook and you start adding cells, and each cell can be just a plain text cell, which I don't use all that often, or it can be a markdown cell. So if you ever use markdown language, like, you know, you're checking things into GitHub or something and you want to make a README, that's markdown language. You can just write your own documentation that goes along with it. And the point of the Jupyter notebook is not necessarily for you, it's for you to share with someone else your entire thought process and the code in a portable way to do some threat hunting. Or you can do anything else. It does a lot of really great things for like large data processing and scientific visualization, whatever. I'm using it for threat hunting. So I started off with just a little bit of documentation, which describes the purpose of this notebook. And then you can see the very next cell there is Python. And what that's doing, I've just got kind of some boilerplate that I put into all my Jupyter notebooks. And by the way, if you didn't already get it, you should have. In the invitation to this webinar, there is a link to this Jupyter notebook, so you can look at it and you can download it on GitHub. You don't need to do it right now, but if you're curious, you've got all the code. So the first part is just boilerplate, you know, checking that we've got the right version of Python that we're expecting, and loading in all of the modules that we're going to need to use. And there's quite a few of them. But the nice thing is if you spin up a Jupyter Notebook server, especially this one, this Jupyter Hunt server, it's got all the things already installed. So it's pretty easy. It comes with all the batteries included. The next thing that you need to do once you've got all of the modules imported is you need to connect to your workspace. This is the database, right? So built into the Mystic Pi modules are ways to connect to Azure Sentinel, which makes sense because it's Microsoft's product that they're selling, and they want to be able to hook up to it. And Mystic Pi is from Microsoft. But you can also use the same module to hook up to Splunk or other databases too. I can't remember off the top of my head all the things that it'll do, but it'll hook up to a lot of things. So that's the cool thing, is like you could just rip out this one piece and replace it and have this Jupyter notebook work with some other data source. So actually in this code block, you're seeing the entire code block there. There's actually just 3 lines of actual code and the rest of it is comments. So we create a new query provider instance. And we tell it that our data environment is log analytics. Log analytics means Sentinel, because Sentinel is actually just built on top of Microsoft Log Analytics. And then we give it the configuration for our workspace. This is in a separate configuration file, YAML file called Mystic Pi config. Yep, that's right. That you specify like all of the connection strings that you need to get access to your workspace. So that's nice because you don't need to be sharing all of that with people who you're sharing this notebook with. You don't want to give them the connection strings into your workspace. You want them to use their own, right? So having config outside of code, always a good practice. And then you just call this query provider connect and pass it in the connection string, and that's it. And then over there on the right side of the screen, this is just a little pop-up. What's the server? Oh yeah, I'm not going to tell you. So the authentication part just pops up a little authentication dialog where you authenticate to Microsoft. So you're not authenticating through this notebook, you're authenticating to Microsoft to get access to your Azure Sentinel interface. Obviously, you don't want other people to be able to access it, and you don't want like a hard-coded API key or something. So this works really well. It's super simple. You just use, like, I've got multi-factor authentication is required to authenticate to my Azure Sentinel workspace. So like I actually have to put in the authenticator code and my password for that to work. All right, so now we're actually to the interesting part where we're gathering the information that we want. I will probably be updating GitHub hopefully soon. When I get some time, I've got a better way to do this, a better query that runs a lot faster. I've been playing with this in the last couple of weeks, and I've got a better way to do this that'll work it'll still get the same results, but it does it like, oh, more than 20 times faster. So a good speed up. All right, anyway, so in this version of it, at least, this is the query that we're using. There's two queries. One of them is the set of queries for Microsoft Defender for Endpoint, if you've got that. And these queries that you see in the red text, those are strings that just represent the KQL query. So since none of you have seen KQL before, I just want to point out a couple of things. So the first line up at the top query is device network events. That's the name of the table, the database table that we're getting stuff from. So in Microsoft Defender for Endpoint, all of the network events are always for everybody's Sentinel or everybody's Defender for Endpoint. It's always called device network events. That's not a name that I made up. And then we're going to do some selection or basically where clauses where we're filtering the results that we want. So we want where the time generated is between some date and time and some other date and time. And if you've ever used Python before, you can see the %s, that's a string format placeholder where I'm going to fill in the actual date and time that I want from beginning to end. I'm going to look for any network connection that was not, that's the exclamation mark, that was not in this list, inbound connection accepted or listening connection created. So I don't want to know about incoming network connections. I don't want to know about ports that are listening, that the process is listening to. I want to know about all the others, which include inbound connections, connection detected. There's some nuances there, but there's a reason why I'm specifying that as a negative condition. And then I only care if the remote IP address is not empty. Like sometimes Defender for Endpoint just screws up and it doesn't record the remote IP. That doesn't do me any good. I need to know what that is. And then I'm going to, the last line there is project. That means I'm just taking these columns. Those are the only ones I care about. That's what my results should be. I can throw away everything else. All I need is the time generated, the local IP address, and the remote IP address. And then we'll get back to this process query later. This is once we've gotten to the point where we've identified a network beacon, we want to look at what the process is behind that. This will just take all of the processes that had to do with that local IP address and that remote IP address. If you can see in that second query, there's placeholders for local IP equals, remote IP equals. We're going to fill in those blanks later. And that's what the Python code will do in the Jupyter Notebook. So hopefully this is making sense. I know for many of you, this is the first time you've seen all of these things like Sentinel, Jupyter Notebooks, Python, and KQL. So it's a lot to take in. Maybe review the recording later or ask me questions. So the next thing that we need to do is actually retrieve all of that network traffic, or all of the network, we're not retrieving the traffic, we're retrieving the metadata about the traffic, all that timing. Remember, we selected the time generated, remote IP, and local IP for every one of these connections. We need to get that back from the database. Now, the first time that I did this and I built this Jupyter Notebook, I was very naive and I ran this against a production environment with lots and lots of computers. And I just said, for a 24-hour period, give me all of them. And it just went for a really, really, really long time. And finally, I got an error back from Sentinel that said the result was too large. Like I can't give you that much data all in one go. And of course, whenever you encounter a problem like that, don't give up. Just think of another way to do it. So I thought, well, if that data was too much for 24 hours, what if I just ask for 1 hour at a time, and then I just append to my own local data structure, which in this case is using Pandas data frame. Very nice way to work with a lot of data. And I just build it up. That worked perfectly. And then I discovered there's this really cool thing for Jupyter Notebooks. What is it called? It's the thing where, oh yeah, it's the T range. So if you see just down from the top, kind of the top third of that script, it says for hour in T range. What that will do is it will display a progress bar. So there's 24 hours that I want to search, and so it's going to build a progress bar from 0 up to 24, and so you get a nice updating user interface while you're waiting for these queries to run. Now, Maybe I should just skip this part because in the updated version of this, you can get all 24 hours worth of data that you need just like that. Well, not just like that, but like in 10 seconds rather than in a bit. This is telling me this was taking like 48 seconds to retrieve the data for each hour. And I ran this many times, and I usually had about like 1.2 to 1.3 billion connections that I was looking at. Once all that data is back, like the slow part was querying it. Once it's back, it's actually really fast to process, even on a underpowered virtual machine. This is what we were basically doing. I was taking each IP address pair and the timing and putting them together into a list so I could see, okay, between this IP address and this IP address, there was a connection at this time, this time, this time, this time, and this time. And then I was calculating the time difference between each subsequent time of the connection, and then just storing those deltas. So like, let's say that I had a connection that was happening every 60 seconds. I would, take the time of one, find the time of the next one, subtract one from the other. Oh, that's 60 seconds. So I'd store 60 in the array for that host pair. Hopefully this is making sense. And then the next one, 60, 60. So I've got this long list that each value is 60. That would be like the best case, perfect beacon, no jitter, really easy to find. Or maybe I'd have one that's just all over. It's somebody's web connection. And they were, browsing kind of randomly, and I might have like 37, 122, 2, a whole bunch of numbers, all which represent the seconds in between subsequent connections. So I build all of those lists. Now I've got those lists. And the next thing that I need to do, whoops, well, I actually skipped through the algorithm because for good reason, it probably take too long to get into it. But I want to tell you, I took the algorithm from Rita because Rita is open source and I really like Rita. I love Rita. I think it works great. So I just basically ripped that off and re-implemented it in Python. The funny thing is Rita used to be Python. Now it's written in Go, so I had to take Go and translate it back to Python. But anyway, it uses some statistical calculations like the mean, what was it? The median absolute difference around the median. I think that's what MADM stands for. And it takes like the number of connections in the time and a bunch of other things, and it puts them together. It has all these different scores, and then it combines them, weighting them equally, and it comes up with a beacon score somewhere between 0, not like a beacon at all, and 1.0, which is like as beacony as it gets. So the next thing that we want to do is display a table of the things that look like beacons. These sliders, this is another thing that is a feature of Jupyter Notebooks you can use, and you can have some interactive UI elements that you run the sliders around and then press a button, and then it will display this really nice, pardon me, data table. So this is some records from an actual commercial environment, which is why there's some redactions here, because I told my client who agreed to let me use their data that I wasn't going to show all of their IP addresses and stuff. So what you can see is very near the top here, there's a couple, actually there's 3 that are pretty high scoring. The top one, the very top, you can see the score is 0.984 out of 1.0. That's really high. And it's between some local IP address starting with 10 dot and some external IP address starting with 72 dot. We can see that the components of the Rita algorithm that computes the score are the skew score, the MADM score, and the count score. So it was high in all of those. Sometimes you want to see that broken down because it's useful to look at things different ways. Some elements of beacons will score higher on one of those, but not the other. And then it tells me the range of intervals in my giant list. So you can see this was between 3602 seconds and 3596 seconds. So basically like once an hour, right? Once an hour, this thing is making connections. And then it told me that in the 24-hour period, the earliest connection it saw was on January 23rd at 7:23 in the morning, and the latest one was January 24th at 6:23, and there were 23 connections. So basically, this is telling me This is a connection almost right on the hour, every hour, 24 hours a day. That could definitely be a malware beacon, right? This is something we want to investigate. The other ones didn't score as high, but they did score high in some areas like the skew score. You can see the second one down. The reason that its score dropped is because the count, because in 24 hours, it only communicated out 22 times, but it was averaging like 300 seconds between beacons. So that means there was a big gap in there. Like it wasn't beaconing all this time. That's what that means. All right, let's get into visualizing this. One of the really great things about Jupyter Notebooks is it lets you render graphs. And graphs to me makes so much more sense than trying to scan through a bunch of numbers. So you've got this code, so I'm not going to go over it because we're getting short on time. But I want to show you the output of running that Python code. This will show you side by side the graph of the connections over time, like number of connections per every 10 minutes. And then it shows you the actual chart of the times. You can look at it either way, whatever makes more sense to you. You can see that this definitely looks like a regular beacon, right? Just visually, it pops out at you like, okay, this is making regular communications. So the next thing we want to do now to answer that question from early on, how do you tell if this is legit or not? Well, you look at the process that was responsible for it. You need to connect the network connections to the process. Otherwise, it's not going to make any sense. Otherwise, you'll just stop at like, well, that looks like a beacon. Maybe we'll block it. But I mean, you don't want to do that in this case. So in this is a real life example. I discovered this beacon. I talked to the security team at my client's organization, and I said, hey, I found something that communicates every hour, on the hour, 24 hours a day, every day. Like I went through a bunch of days. This is always running. Is this normal? Because I've never heard of DT exec running on your SQL server. And the security team also had no idea that this was going on. They're like, well, what IP is it talking to? And I gave them the IP. They're like, oh, that doesn't make any sense. Like, what is this? They got really worried too. So they reached out to the user who was running this particular server, the admin, was a server admin, and said, hey, what is this thing? Why is DT exec communicating to this external IP address every hour on the hour? And they got back the answer, oh, this is expected. This is actually something that, I'm not going to go into it, but it was fine. And then that's great. Okay, well, we don't need to worry about DT exec ever again. Or that IP address, because it's always talking to the same IP address. So this is the general way that this works. Like this, on a regularly recurring basis, we go hunting for beacons. We identify what's behind it. We find the ones that look kind of like they could be suspicious. We ask the person responsible for the computer to find out, did you mean to do this or not? And sometimes the answer is, no, I have no idea what that thing is. And then we really go to incident response mode. But most of the time, it has a reasonable explanation. We need to add that to the allow list. We need to make sure that we've noted that so that it doesn't keep coming up and being part of our threat hunt. Like we don't want to keep hunting the same things over and over again. So I already have, if it's DT exec, don't worry about it, or at least on this particular machine. So I want to show you some of these other ones just so you can see like what some of these look like visually. All of these look a lot like beacons. The number on the left is the number of connections per 10 minutes. Have a library of exceptions? Yeah, basically, we just bake that into the KQL. The KQL query can say, don't return the data if it's associated with whatever parameters you want. So like in this case, I'll say, if it's DT exec on this host, don't worry about it. Don't return the data. Here's one that is not a beacon. So you can see at the beginning of this communication, there were a whole bunch of connections right off the bat. And then there were kind of regularly recurring connections, but not really, like they're not all that even. Don't completely ignore this because this could actually be a malware communication pattern. It's just not a usual malware communication pattern, but this at least rises to the level of being kind of interesting. So now let's stop looking at an actual environment where there was no malware running, and I want to run through some actual malware because, I mean, we wanted to kind of prove this hypothesis if this would work. So we did three different things. First, we had Baza loader, which loaded Baza backdoor, which communicated regularly to its command and control. Next, we tried Cobalt Strike because that's a very common tool both for red teams and threat actors. And then I rolled my own custom Visual Basic script RAT that called out to Google because that raised all kinds of interesting questions, and it's a legitimate Google IP. So I'm not going to go over the details, but this is the same event query for Sysmon rather than for Defender for Endpoint. And here are the results. So the very top one there, that is Baza backdoor. That's a actual piece of malware, and that 45.14 address, that's a real threat actor piece of infrastructure that they leased. You can see the score was super high, 0.982. Like if you see something like that, it is definitely something you want to check out a little bit more. And then you can see that the beacon interval kind of varied. Like sometimes it was 300 seconds between beacons, sometimes it was 100 seconds between beacons, and in 24 hours we had 307 of them. Okay, and I think that one was like every 5 minutes, if I can remember right. Yeah, something like that. And then every once in a while, it did some extra ones. And then you see the next three down, they were actually the next four, they're all communicating to an IP address starting with 172.217.2.110, right? So that's really interesting. That's actually a Google IP address. And if you've never played around with script.google.com, you definitely need to. You can, for free, with just a Google account, you can create a script that is listening on Google servers on port 443 and can accept posts and gets and has program logic that you write in JavaScript and can like forward connections onto other servers and can return things directly from Google. So that's what I was doing there. And the thing is, when you query DNS for script.google.com, you sometimes get different IP addresses back because it's load balancing, right? It makes sense. It's Google scale. It's not always going to give you the same IP address. That's why there's multiple IP addresses. And I wanted to see if this would work. Sure enough, with script.google.com, you mostly get the same IP address. You can see like 1,246 times I got that top IP address, and then 692 times I got that other one. And all of these scored really high on beacon score. So this is what Baza backdoor looks like in the visual graph. It definitely looks like, yeah, I was right. It checks in every 5 minutes. This, if you see something like this is definitely a beacon of some kind. And then when you look at the process behind it and you see that it's command.exe, like seriously, do you think command host is supposed to be communicating to some external IP address posted in wherever every 5 minutes? Like that's ridiculous. This is something you definitely need to investigate. So this was actually Baza backdoor injected a remote thread into command.exe. So it's not like a fake command.exe, it's the real one. It just has malware code injected into it as a thread. Here's my Google script backdoor. Ooh, that's really noisy. And also it is very, very regular. So you can see kind of the regular patterns there between 9 and 10 connections every 10 minutes because I set it up to communicate exactly once every 60 seconds. And this shows you the files that were, the processes that were talking to it. It's mostly C script because it's a Visual Basic script backdoor. So of course it's running in C script. But there's also teams. This is interesting, right? I was just looking at the query is what are the processes that were talking to this IP address? When you have malware talking to Google IP addresses, you get lots of other stuff that also was talking to Google IP addresses. In this case, Teams was. That was legit, but there was only one, so I didn't really care. Really that top row, the row 0, is what's most interesting. And then here's Cobalt Strike. So this one actually scored fairly low, right? The score was 0.57, which probably wouldn't have risen to the level of wanting to look at it. But this is because the threat actor who was using the Cobalt Strike beacon was starting it and stopping it. And so in this case, this didn't really stand out this well. And this is really good to find those like edge cases or those exceptions to your hypothesis that show that maybe you need to look at things a different way. So when we look at this, we can see that the skew score was actually pretty high. That was interesting. The median absolute distribution around the median was kind of low, and then the count was really low. So sometimes maybe what we need to do is not just look over a 24-hour period, but look at like smaller segments, because if we looked at like a quarter of this day at a time, this Cobalt Strike beacon totally would have stood out. Microsoft Teams, just for fun, like it kind of looks like a beacon too. It makes a lot of false positives, but the nice thing is, it's Teams, it does that, so you can just add that to your allow list. And that's it. I hope to end a little earlier. We're kind of right at time, but I'll tell you what, I'll stick around for a little bit if there are more questions. And I think I answered all the questions in the chat as they came up. So anything else that you'd like to know before we end?
Well, we've got a couple questions. Let's see. Not sure if you covered these, Randy. First one was, how does Rita compare to Wireshark from earlier?
Oh, I did cover that. So that's the thing that's like
Okay.
apples and oranges. Rita is not the same thing as Wireshark. It doesn't cover the same uh, uh, use cases. Like it's a different tool. It's like hammer and a screwdriver.
Gotcha. And one person joined late and was asking if you gave handouts, code snippets, or links that went along with your presentation.
Absolutely. It was sent out in the invitation to this presentation. So it's on GitHub and you should see that. If you don't, let me know. I'll send that to you again, David, and you can email it out to people, but everybody should already have that.
Great. I'm sure others will ask whether, will you be sharing the slide deck at all with the audience?
You know what? I'm happy to do that. Can I just send it to you and you can send it out to people?
Yeah, in the past, we've posted on CSMP's site, just corresponding to the event.
Okay. Yeah, sure. I can do that.
I've got a couple more questions flowing in if you've got the time, Randy.
Sure. Yeah, I'll stay.
Dave Cho is asking, are there any other legitimate software that send out beacons like
Oh, yeah.
Malware do?
Yeah, absolutely. So anything that is checking for updates regularly, you probably want to allow list all of your web browsers. It is possible for malware to inject into web browsers, and I have seen that myself. But where you get the most false positives on beacon hunting is from web browsers, because all you need to do is have one employee go to a website that has like an auto refresh. Every 30 seconds, it goes out and gets another JSON payload and like updates the web page. That looks exactly like a beacon. It is a beacon. But when you examine it, you can see, oh, it was Chrome reaching out to this website. The last one that I found was actually updating live price of ammo for somebody who wanted to, buy ammo when it was cheap. Yeah, those are the things that look like beacons. There is no way for you to say that everything that looks like a beacon is malware. That's why it's threat hunting and not just an automatic alert. But the cool thing is, the most malware does stand out, like among the little bit of noise that you'll get. And in a pretty large production environment, I might find like 3 beacons a week. So it's not that much, not that much to look through. You will definitely find any malware that uses this sort of communication pattern.
I really love the forensic heavy side to this operation of looking for things. I've always enjoyed that part of this work. Sean Wilson is asking, do you have a library of false positives to exclude?
Oh, you'll figure that out really quick. It's environment specific. My only recommendation would be exclude Teams and web browsers right off the bat, and then you'll save yourself a lot of trouble.
Mark is asking, there's so much to ask, not sure where to start. I feel the same, Mark. I have so many questions for an expert like Randy. In a SOC environment, how would you use the tools that you demonstrated?
Oh, perfect. Yeah, I can answer that because we use it in a SOC environment all the time. So what you do is just make a point to carve out like, 20 minutes, maybe 15 minutes out of your day. And the frequency is up to you. You could do it every day reasonably, or you could say like twice a week, I'm going to go look for beacons. It's just a matter of, how much time you've got to devote to it. But I'd say, if you do it every day, probably spend 10, 15 minutes. That's not so bad. And then just, at the end of the day, at the end of your shift or whatever, or maybe you don't want to find the intrusion right at the end of your shift. Maybe try the middle of your shift. You've still got some time to work on it. Do this threat hunt, find whatever looks like beacons, chase it all the way down to figure out, is this malicious or is this normal? If it's normal, add it to your library of allowed list, so that you don't have to hunt it again and nobody else has to either. And then just go on. And I would say most days that I run this kind of a threat hunt, I get 0 results, like just none. So I don't even need to look for anything. It's pretty quiet that way.
I had a person in the audience ask earlier how they could follow or connect with you online. How would you like to share that? Do you want to share your LinkedIn?
Yeah, LinkedIn is just
okay. Let me post that into chat.
Great, thanks.
Let's see. I have another question. I'm not sure I answered that. I understand that one. Sorry, Shane. Mark asked again, could you integrate this into a device like CrowdStrike instead of using Yara tools?
I don't know what you mean by Yara tools, because we didn't talk about Yara at all. But CrowdStrike does exactly what CrowdStrike makes it do, if that makes sense. Like, you can do SPL queries for the Splunk instance that's behind CrowdStrike. And you could probably do something like this, but it would be very difficult. So I would say if you wanted to do it with CrowdStrike data, the way that I would do it is I would take the CrowdStrike data and I'd export it into something else, and then use that to query it, and do that on a somewhat regular basis. Here's the problem that I have with CrowdStrike. And I'm not knocking CrowdStrike at all, because I do think it's a fantastic tool that gives you a lot of visibility, and I work with it all the time. What I don't like is that because of the model where CrowdStrike hosts the servers and allocates the resources to you, if you want to do a really intensive search, like something that's going to require a lot of data processing, either you're going to wait a really long time, or it's going to time you out and log you out before you're done and say, I'm sorry, you can't abuse our servers that way, right? Because it's not your server. You're not really paying for the server. You're just paying for a reasonable use of it. So that's where anytime I'm trying to do big data crunching with CrowdStrike, I always get a little frustrated.
Gotcha. And was what you demonstrated a form of automation, or was that more of a manual process?
So it is in the Jupyter Notebook form. It is a combination. Like, there's a whole lot of automation built into the Jupyter Notebook, but you as the analyst need to go into each cell and click play to run it, and then you need to put your eyes on it and understand what you're looking at. So that part is manual. I actually have, since I put together this Jupyter Notebook, come up with a way to do this purely in KQL. So you can do it in Sentinel without a Jupyter Notebook at all. It's not quite as good, but instead of all of the statistical computations that I borrowed from Rita and wrote into this code, just replaced all of those with one standard deviation computation, because standard deviation is built into Sentinel. So using that, which is not as good, but I'm learning to think it's pretty good. Like, it's almost as good. It's almost like a 95% solution. I'm able to automate that and have a schedule where, like, once every 24 hours or once every 6 hours, Sentinel runs this query. It has all of the allow lists that it already has built into it. And it'll like send me a message in Microsoft Teams if it discovers something that it thinks I should look at. And then I don't have to do all the rest of this process. I just need to do the poking around and figuring out if this really is a beacon or not.
Gotcha. Yeah, there's definitely like an indispensable human element to this, which is really interesting to discern what is a threat and what's not a threat. I think that part's probably the fun part.
Yep.
I imagine. There's a wall of questions coming in. How are we doing on time, Randy?
I kind of want to eat dinner at some point. But, let's see. Process hollowing is real.
I've got 7 open here. We can do a couple more and then call it a night, or up to you.
Yeah, sure. Let's do that.
Okay, a couple more here from Wesley. Do you find that Jupyter Notebooks provide more utility than tailored dashboards in Seams?
Oh, yeah, absolutely. It's a different sort of thing though, right? Because like a tailored dashboard is sort of sitting there and you can just glance at it any time. With a Jupyter notebook, you have to run it. Like it's always the point in time when you run it is when you're getting the results. What I like about Jupyter notebooks better than anything else is it's totally open-ended Python program. So if I can dream it up in Python, I can make it happen on the screen. That's what I like. All of the dashboards I've ever used in any sort of security solution are always very limiting. It's like it's whatever the designer thought I probably wanted. That's all I've got.
Yeah, and if you're one of my students watching this, I did not pay Randy to say that. That's exactly why we learn Python in class, is because tools are tools, right? They come out of the box a certain way. That doesn't mean they meet the needs of your environment. So that's where the power of knowing some of that coding really pays off later on.
Absolutely.
We'll do this last question from SK here. Anything you could recommend to develop in this field, such as projects to follow, blogs to read, books, resources like that?
Oh, so many. I could just go on and on. That's like the question. That's like the when you ask the genie for never-ending wishes wish, right? Like that's a whole nother talk, really. But let me just say, if you have not played around with Sysmon yet, you definitely owe it to yourself to check it out because it's totally free. Like you're not going to pay anything other than your time to learn about Sysmon. And let me tell you, like in actual industry, working with a lot of different clients, a lot of different companies, there's tons of people out there who are super interested in how to implement Sysmon that don't know how and don't know how to figure it out themselves. So if you are someone who can come in and say, oh yeah, like I know exactly what you should do with Sysmon, here's the config for you, and you can do that confidently and like get it hooked up to whatever they're using, Splunk or you know, Sentinel or anything really, you can have a lot of work just consulting using Sysmon. Um,
Mm,
as far as people to follow, let me recommend Olaf Hartong. He's a super smart guy, really nice guy in the Netherlands. If you go to falconforce.io, every Friday? No, I think every other Friday, Olaf posts a Falcon Friday query where he gives people like a really cool tip on threat hunting and how to do queries. Mostly he uses KQL. I'm not sure if he's going to start using some other things too, but definitely one to follow. Also just a nice guy. I mean, his name is Olaf, and on his Twitter, he's got a picture of Olaf the snowman with his face pasted on top. So like, he's kind of fun.
that's great. And where I like to start, if I'm teaching somebody these concepts, I like to start like right with Rita and Zeke, just some basic tooling.
Yep.
And that page that you called out, active countermeasures,
Mm-hmm.
that group, they've made some really good like starter lab activities up there.
Oh yeah.
So if you just want to just play with the tooling for the first time, I that's where I would, so that'd be a good place to start, I think.
Yeah, Active Countermeasures has a free threat hunting webinar pretty regularly. I think one is coming up like this week or next week or something. So check
Hmm.
that out too.
Yeah, I just kicked off the feedback polling. Thanks everybody for your responses there. Super helpful. And Randy, it sounds like your dog needs dinner too over there.
Mm-hmm.
Uh, thanks so much for dropping in. I always enjoy just going, straight up technical. How do we stop these threats? What are the tools we use, and how do we use those tools to get the job done? And then how do we all get better at this, right? Like that's what I'm all about in my day-to-day work, and it's so cool to see these tools represented. And also, I thought it was cool to see how big of a role that mathematics plays
Mm-hmm.
in the analysis of whether this is a threat or not. So I thought that was very, very cool to see the answer to when do I ever use math in real life. I feel like my high school teacher should have seen this.
Yeah.
Um, but yeah, thanks all everybody for joining our weekly Wednesday webinar for CSNP. It's not been every week this year, but we're pretty dang close. And next week we've got our how to set up your home lab type of presentation coming up. So please, if that's something you're working on, we'd love to have you. I'd love to answer your questions as to how to set these kind of simulations up safely at home and build your skills that way. So also shout outs to Sai Sharma. You've been answering a ton of questions and proposing a ton of ideas in the chat. So if you're looking for experts like Randy, I recommend, highly recommend talking to Sai Sharma. He's on our CSMP Slack. So feel free to join our Slack community and say hello as well. Otherwise, you can find us on csmp.org. Follow us on LinkedIn for all our latest events. We post these on Eventbrite. So be sure to stay up on all of that. Otherwise, good to see you, everybody. Thanks so much for joining. Appreciate all your interaction and questions. And I hope you've enjoyed the threat hunting demo today. So thanks again, Randy. And that's a wrap. Good night, everybody. We'll see you next time.